In this video, I will be deriving the equations we need to get at the change in enthalpy of our system, starting with the energy balance equation. So, since this is an adiabatic flame, the internal energy of the system does not change. So we can set our equation equal to 0, and the change in enthalpy will be the enthalpy of the products going in times their mass minus the enthalpy of the products going out times the mass of the products going out. And so this is the same as writing the enthalpy in to the flame will be same as the enthalpy out of the flame. So we can get at the change in enthalpy through the partial derivative of the enthalpy with respect to time at a constant pressure times the change in temperature. So I'm going to go ahead and rewrite this. This can be written as the heat capacity at a constant pressure times the change in temperature. So usually this value is understood to be constant, but since we are at such a large temperature range, starting at around room temperature, which is 298 kelvins, and burning the product, it'll reach roughly about 2000 kelvins. Because we have such a large temperature range, we are actually going to have to integrate an expression to find that value. It'll be the integral of our change in enthalpy from the first value to the second value will be equal to the integral of our constant value, or our constant pressure heat capacity times the change in temperature from the first temperature to our second temperature. And so in the next part of the video, I will be using an expression to find the integration for our constant pressure heat capacity, and then from there we'll be able to find the temperature of the flame.